Boleh dengar suara saya sekarang? Tes. Suara. Suara boleh dengar? Okey. Okey, jelas sudah. Okey, saya akan share screen. Okey, saya akan share screen. Okey. Oh. Boleh nampak skrin dan boleh skrin dan dengar suara. Okey. Boleh nampak skrin dan dengar suara sudah, saya rasa, because tadi ada saya tidak tertekan apa? Ini. Okay, so jadi kita mulakan untuk yang chapter 2. Actually chapter 2, the title of the chapter 2 is Kinematic of Linear Motion. Right, so kinematic of linear motion. So first, for chapter 2, we have 3 subtopic. The first subtopic here is, sorry. Okay, motion, right? So this is kinematic of linear motion. And next we have linear motion, one-dimensional, and uniform accelerated motion, and last projectile motion. So this is the 3 subtopic. 3 subtopic we'll cover for chapter 2. So today we try to finish at least linear, one-dimensional, and uniform accelerated motion. We go to the next slide. The slide you can refer to the lecture note that I gave you in the Google Classroom. So you can use the lecture note here, the same lecture note. Okay, linear motion, 1D. 1D meaning this is a one dimension, right? So one dimension. So first, distance. So the symbol of the distance is D, distance. Actually, we have distance, and the next we have displacement. I think the chapter 1 we have already discussed about what is a distance and what is a displacement. So again, distance is a scalar quantity. Scalar quantity means the distance only have a magnitude or nilai saja. Let's say we have 2 centimeter. So this is the meaning the magnitude. So no need for you to describe the direction of the 2 centimeter. So no direction, and that's why the distance is scalar quantity, or it's defined by the length of actual paths between the 2 points. Let's say you have the point P and you have another point Q. So the distance from point P to point Q here, the distance here you can measure, maybe you can use a meter rule, okay, guna pembaris or guna petameter dan sebagainya. So you just measure the distance here, or the length of the path here is 25 centimeter from P to Q. So this is how to measure the distance. Okay, so this is what is a distance. Next, we go to the displacement. Okay, so what is a displacement? So if the distance, okay, as I said earlier, distance is a scalar quantity. Displacement is a vector quantity. So meaning if you talk about the displacement, you must consider the first magnitude and you must consider the direction, right? The direction and magnitude. So this is a vector quantity. So the displacement is defined the distance between initial point and the final point. So if you compare to the definition of the distance, yang tadi kita tengok from P to Q, so you measure the long path length of the from P to Q. But if you talk about the displacement, you just consider where is your initial position at point P, where is the final position. This means from initial position to the final position here. So this is a displacement. So meaning displacement initial to final position. But if you talk about the distance, you must measure the paths or length of the paths from P to Q. So this is a distance. So this is how you can differentiate between displacement and distance. And distance, you must, because of vector quantity, you must consider the magnitude and direction. So let's say you have the velocity 3 meter per second. Meaning if you talk about the 3 meter per second, the first you must have the speed or the velocity 3 meter in 1 second. But you can ask what is the direction of the object with velocity 3 meter per second? To the right, to the left, upward, downward, and upward. So meaning must have a direction. Okay, class? So this is how you can, the simple process or explanation that you can use to differentiate between distance and displacement. So we go next. Okay, this is example, so you can study your own and just go through. Okay, the next is speed. Okay, student asked me, what is the difference between the speed? So first we have the speed, what is the difference between speed and velocity? So now we try to differentiate between the item speed and velocity. So first, we talk about the speed. The symbol is also V. That's why the student confused. Which one V is referred to the speed or this is referred to the velocity. So we go to the definition. So definition according to the lecture note here, speed is the rate of total distance, right? The rate of total distance. So meaning I focus on the item distance here. Total distance, meaning kita boleh ukur berapa jarak yang dilalui. So tadi kalau kita bagi contoh from P to Q, so we have the length of the paths from P to Q. So kita boleh gunakan pembaris atau pita pengukur ukur. So what is the distance? So this is a distance, right? So I go to the next slide. Compared to the definition of velocity, right? So velocity is talk about the rate change of displacement. So meaning when you talk about the speed, also the symbol speed and velocity is the same symbol, right? Okay, this is a velocity and speed. Speed is, right, focus on the distance. Okay, distance, as I said earlier, this is a scalar quantity. Okay, this is a scalar quantity. And the velocity is focused on the displacement. Okay, this is a vector quantity. So this is scalar quantity, this is vector quantity. So meaning here, speed is the item scalar quantity, also like distance, and velocity is a displacement, and vector quantity. So speed is a focus on the magnitude only, and the velocity must have a magnitude or nilai magnitude, and we have so vector meaning we must have a direction. So this is how you can differentiate between the speed and velocity, right? If you look at the lecture note here, back to the speed, right? So the speed is a equation to the speed is total distance travel. Total distance travel and divided by time. Okay, so anything when you talk about the rate, ingat ya, kalau kita berbincang mengenai rate is a kadar kadar, maksudnya kita divided by time, so kita merujuk kepada is how fast, is berapa cepat. So maksudnya total distance, let's say from P to Q, berapakah masa yang diambil, and kamu ukur what is the time taken from P to Q. Time is time taken from P to Q, and you must measure the length of the distance from P to Q, or total distance travel divided by the time, or V is equal to, this is total, sigma here is meaning total distance travel divided by T. T is time. So this is how you can find the formula for the speed, right? And as speed is a scalar quantity. This is a scalar quantity. So just consider the magnitude, right? Okay, so next we go to the velocity. So velocity is a first vector quantity, and the unit is meter per second. The same unit, speed is also unit, speed also unit meter per second, right? So for the velocity, so we have first as average velocity. So what is the average velocity? Average velocity, or the symbol is a V is velocity and subscript AV, this is average. Average velocity. So definition of average velocity is the rate of change of displacement. Or dalam bahasa kita katakan kadar perubahan jarak ataupun displacement. The rate change of displacement. Same we have the rate, meaning you must divide it by time t or time interval here. Or we can use the, you can see here the equation to calculate the velocity average is the triangle here. The triangle meaning there's change. Ini maksud dia, kalau masuk triangle kat sini ni, this is change. Change meaning the final S2 minus initial and the T2 minus T1. So I give you an example here. So let's say we have the point P here. At the point P, you go to the, let's say the point Q. This is the point Q. So now the distance from P to Q, from P to Q, the distance here is 10 meter. So now, if the time taken from moving object from P to Q, let's say the time taken, so this is a distance, right? 10 meter. And the time taken, let's say 2 seconds. So now you can find the velocity of the object is a displacement s divided by time t. So now, the displacement or distance from P to Q is 10 meter and divided by time t is 2 seconds. So now we have the 5 meter per second. So now for the velocity, as I said, the velocity is a vector quantity. So first you must have a magnitude, 5 meter per second, meaning the change of the displacement of 5 meter in 1 second. But the direction of the object is from P to Q. So because the velocity 5 meter per second is a vector quantity, first you must have a magnitude. And then next you have a direction to the right from P to Q. Because the question about the, ask you about the velocity. You must know the magnitude and you must know the direction. So direction. Okay. So let's say the, okay, back to the definition here. S2, S1, T1, T2. So how you can initiate that the where is the S1, S2, T1, T2. So meaning here, S1 you can use the S1 meaning the initial position, right? And S2 is a final position. And the T1 is initial time. After object travel to the Q, so object take time, let's say T2. So meaning, if you refer to the equation, the velocity is the delta T. Delta here, delta S meaning change of displacement. Change meaning S distant final minus distant initial. So meaning distant final is a S2 and distant initial is S1 and divided by the final divided by delta T, the change of time. Change of time meaning T final minus T initial. T final is a T2 minus T1. So this is how you can use the equation or the formula to describe the velocity of the system. So same process, if you look at the lecture note here, so we have here this is a V average, the delta S divided by delta T. Next, so we go to the next slide. Okay, so the next slide. Okay, we have another type of velocity here. So what is the another type of velocity here? So we have instantaneous velocity. So if you talk about the average velocity meaning this is average. So meaning from P to Q, we have average velocity from P to Q. But if you talk about instantaneous meaning, so we want to know, let's say this is T1, this is T2, this is T3, this is T4. So meaning we try to calculate or find the time or the speed, the velocity at the certain time T. Let's say at the T4. At the T4, what is the velocity? So we need, instantaneous velocity is not about the average velocity. We talk about the at the certain time T or dalam satu masa-masa yang khusus kita nak tahu. So this is equation. So if you keep the equation here, so this is mathematics, mathematics are the equation that you can use to describe the equation for instantaneous velocity. But if you compare to equation, if the average velocity, the previous slide, so we have equation delta V divided by delta T or S2 minus S1 divided by T2 minus T1. So we need the change of the displacement, change of the time T. But if we talk about the instantaneous velocity, we focus on the at the certain time T, pada masa-masa tertentu, right? So this is how you can differentiate average velocity and instantaneous velocity. The unit is same unit, meter per second. Okay, so we go to the next slide. So the next slide we talk about the graph ya. So graph ni saya akan cerita lepas ini nanti ya. Saya nak pergi terus kepada acceleration. So first hari ni kita akan tengok item yang first tadi kita tengok mengenai, okay, saya ulang balik kat sini. So you saw about the distance D, okay, and we have a displacement and we have the velocity. We have the speed, we have the velocity, we have two types. We have the average velocity and we have the instantaneous velocity, and then next we have a acceleration. So today we try to cover this item. Okay, look at the lecture note. So definition of the average acceleration. So first we focus on the acceleration here. The symbol acceleration is A, right? And this is a vector quantity, so same to the vector. So if you talk about the acceleration, you must focus on the magnitude and the direction. So meaning you have magnitude and direction. And the unit is meter per second square, okay? Meter per second square or ms minus 2. This is a unit for the acceleration. So acceleration, same like the velocity, we have the average acceleration. So A average. So the rate change of velocity. So average acceleration is the rate change of the velocity. So meaning if you have the delta t, this is rate, is kadar, betapa cepat. Okay, delta t, we talk about the delta meaning we have a v final or v2 minus v initial and divided by delta t is a t final minus t1. So this is the average velocity. If you look at the definition given by the lecture note here, is define the rate change of velocity. Yes, look at the equation here. So A average is equal to V2 minus V1, T2 minus T1, and average is delta V divided by delta T. So I think we will talk about the theory. Nanti at the next slide, we go to the sample example of the question. I think we more apa orang kata lebih jelas bagaimana penggunaan acceleration, velocity, distance, and displacement dalam penyelesaian masalah. Okay. Okay. So the next, we go to the next slide. Okay. The same for the velocity, we have also instantaneous acceleration or A. So instantaneous acceleration is focused on the equation is dv dt at the certain time t. What is the acceleration at the certain time t? So this is a instantaneous acceleration. Okay, I think we talk about or discuss about the graph, so we can is more understand and how you can use the instantaneous acceleration, how you can use the acceleration, same process to the velocity or instantaneous velocity. So this is just a theory or definition of the item A, V, D, and S. Okay. Okay. So now, okay, the acceleration graph. Okay, and graph. Okay. So now, saya ingat sudah lengkap bagaimana kita sudah mengenali beberapa item. So next, macam mana kita nak, okay, kalau kita tengok kepada lecture note, okay. So we focus on the graph. So now, so the concept of the acceleration, velocity, displacement, and distance. Okay, we try to relate the item here to the graph. So graph S versus T. S is displacement, time versus T is time, right? And ST, this is the curve graph, and this is the straight line and the curve graph. Okay, graph ini straight line, lepas tu dia mendata, and the curve graph and positive negative. So macam ni kita belajar ya bagaimana kita nak membaca graph. Tadi kita bincang mengenai definisi bagi term-term untuk berkaitan dengan acceleration, velocity dan sebagainya. So untuk membincangkan mengenai graph ini, saya nak bagi satu contoh. So contoh ini kamu boleh rujuk ya dekat channel YouTube tu. Ini untuk channel YouTube kita juga ada pensyarah yang buat lecture note. Cuma kat sini saya nak tunjuk ya satu video. Ini bagus ya lecture note yang disediakan oleh Mr. Pack. Nanti kamu boleh pergi dekat channel Mr. Pack, kamu tengok satu video yang dibuat. Saya cuma pakai kat sini ya. Okay. Boleh nampak saya punya screen ya. Screen, this is a YouTube screen tu kan. Okay. So channel ini sebenarnya channel Mr. Pack pensyarah fizik. Kalau kamu tengok ya. You go to the Mr. Pack. Mr. Pack explain fizik ni. Okay, ya akan jumpa lah. Okay, banyak juga nota-nota dan sebagainya. Okay. Ataupun mungkin ada student Mr. Pack kat sini. Saya rasa dia sudah biasa dengan channel yang ni ya. Okay, so if you look at the here, okay, ini adalah objek ya. This is duct. Okay, this is duct. Okay, satu objek. Sekarang ni dia berada pada jarak 10 meter because this is a meter, right? This is 10 meter, right? So 10 meter. Okay, and this is the graph S versus T. S is displacement, T is time T, and this is graph V versus T, velocity versus T, and this is graph acceleration versus t time. Okay, so now if you look at the graph here, we have a different type of graph. S versus t, we have a magnitude of displacement 10, right? Okay, and graph v versus t, we don't have a magnitude, but this is 0, right? This is 0. And this is acceleration versus t, this is also 0, acceleration versus t. So, maksudnya kat sini, if the position of the dart, titik ini berada daripada titik kosong dan dia bergerak 10 meter. Okay, pada jarak 10 meter. So, meaning here, titik itu berhenti pada jarak origin point 10 meter from origin point. So, if you plot graph, pada satu masa tertentu, titik itu berada pada masa 5 saat, 5 second at the 10 meter from the origin, right? Itu cara bacaan dia. Okay, but this is the static. Titik itu tidak bergerak. This is static. Static. Titik itu tak bergerak, dia berhenti. Cuma dia daripada awal, daripada second, 0 second to 5 second, the object stay at the 10 meter from the origin. So now, this is the graph, how you plot graph S versus T. So maksudnya kalau titik itu berhenti pada jarak 10 meter kat sini, so graph displacement versus T here is 10 meter. Itulah dia punya graph dia. Sampailah kepada this is saat yang ke-5. But this is static. So meaning static meaning no velocity. That's why graph here is a 0. And no acceleration because static, so no acceleration, right? So this is the graph. How you can describe is the position of the dart at the 10 meter from the origin. Okay, so now, okay, kita tengok video ni dulu, right? So kalau kita tengok kat sini, video ni, apa akan jadi? Right? Okay, this is just penerangan. Okay, saya nak tengok graf. Okay. Okay, saya rasa kamu boleh, sorry. Boleh nampak Okay.
So, let's see the dart.
You can see this is the direction of the dart. Direction of the dart. From origin to the 50 meter. So dia punya pergerakan itu semakin laju. Okay, kalau kita boleh tengok sekali lagi kat sini, pergerakan dia tu dia semakin laju.
The gradient of displacement graph is actually the velocity.
Dia semakin laju.
So
kalau kamu
velocity is.
Okay, sorry.
The dart is moving to the right at constant
Maksudnya
velocity.
kat sini, kalau kita tengok pergerakan dia tu semakin laju daripada awal sini pergi sana. That's why kalau kamu tengok from 0 second to 5 second, the object ataupun titik itu bergerak dengan laju. This is dia bergerak dengan laju. That's why kalau kamu tengok grafnya daripada kosong kat sini, titik itu semakin laju. That's why dia punya increase from 0 to 10 meter per second. In
velocity is constant. Velocity
0 to 10 meter per second
Velocity
in 5
constant.
seconds. So maksudnya dia bergerak dengan constant velocity V. That's why graf ni dia lurus.
Horizontal.
Okay.
Because no acceleration.
Okay.
No speeding up.
So
no
next,
slowing down.
because
Acceleration
V constant, dia tidak ada pecutan. That's why the acceleration is equal to 0. So graf
moving
ini adalah
object with
kosong,
acceleration.
right? 0. Okay. So we go to the next. Kamu boleh tengok dekat video ni sekali lagi sini. Kalau kita tengok. Okay, saya cuba adjust video ni. Cuba tengok titik tu bergerak macam mana. Okay.
Moving object with acceleration.
Okay, so you can see
The dart is accelerating to the
dia
right.
bergerak itu semakin laju, right?
Become faster
From
and
initial to
faster
final, dia
become
bergerak
faster
semakin
and faster
laju.
to the
Dia
right.
bergerak semakin laju ke depan,
The
semakin
duct move
laju
from
ke depan. So
origin
meaning
0
kalau kita
to
lukis graf
25
S
meter.
versus T,
So the
dia
displacement
bergerak
graph
semakin laju. This
increases
is the
from
curve
0
graph.
to
Meaning the
25
curve graph
meter.
kat sini, kalau kamu
And the
cari
displacement
gradient
graph is
ataupun
curving
kecerunan
upward
graf, dia akan semakin
because
meningkat. Ataupun graf
the
ini semakin
velocity
curang ke
increases.
atas, dia semakin laju.
The
So
gradient
dia
of
semakin
displacement
laju,
graph is the
meaning
velocity. Velocity increases.
V itu
So the
semakin meningkat
gradient of
from
displacement
0
graph
to
also increases.
10 in 5 seconds. Kalau
Acceleration.
kamu tengok graf yang sebelum tadi, kalau titik tu
Velocity
bergerak constant
from
ya, dia
0
bergerak constant,
increases
dia
to
tidak
10.
meningkat, dia akan bergerak
Velocity
dengan constant V.
increases
Graf dia
with
macam tu, V
acceleration.
versus T.
Become
This
faster
is
and
V,
faster. Velocity
right?
increases.
So
There is
dia
an
ada pecutan. That's
acceleration.
why kat sini dia punya acceleration is equal to
Moving object with
acceleration here
deceleration.
is equal to 2,
See the duct?
right? So acceleration
is slowing
is
down.
equal to
The duct is slowing down.
okay. Yang ni pula kalau kamu tengok the next here, kalau kamu tengok kat sini, titik ni dia bergerak daripada laju, lepas tu dia semakin perlahan. That's why dia semakin laju, maksudnya semakin laju, dia laju, lepas tu semakin perlahan Awal dia laju, semakin perlahan dan dia berhenti. Okay. Dia berada pada jarak 25 meter. So, maksudnya kat sini daripada awal dia tu 10 meter per second. Lepas tu semakin kurang, sehinggalah pada saat yang kelima, V dia adalah kosong. So, kalau kamu cari kecerunan kat sini, kecerunan dia adalah negatif. That's why acceleration is a negative. Okay. So, kalau saya nak permudahkan kat sini so we talk about the first is a displacement versus time t. So the first graph is graph yang pertama tadi kalau kita tengok katalah this is 10 meter. So the 10 meter in 5 second. Okay. So maksudnya kat sini kalau dia cuma berada pada jarak 10 meter daripada bergerak daripada sini pergi dekat titik A, pergi dekat titik B sejauh 10 meter, maksudnya kat sini so static at here, tidak bergerak kamu berada kat sini. So if you plot graph from S to graph V versus T, graph kita adalah zero velocity here because jasad ini tidak bergerak. Tapi kalau kita lukis graf A versus T sama juga because jasad ini static, also acceleration is equal to 0. V is also equal to 0. So the next kalau kamu tengok graf kedua tadi S versus T, jasad tadi dia bergerak laju semakin meningkat, bergerak ke depan. So maksudnya graf dia adalah graf, this is a graph straight line. So kalau kita tukar graf ini kepada graf V versus T, dia kalau kamu cari because straight line, if you calculate the gradient of the graph kecerunan graf ni di mana-mana saja kat sini, kamu dapati gradientnya adalah constant. Maksudnya V dia adalah lurus. Tapi kalau kamu convert graf ini kepada A versus T, because constant velocity meaning zero acceleration, dia tak ada pecutan, dia bergerak dengan V yang seragam. This is a constant V. Meaning A is equal to 0. So next graph, kalau kita tengok, graph yang terakhir tadi, saya tengok kat sini lebih jelas graph dia tu. Kalau kamu tengok, pergerakannya daripada awal tu, dia semakin perlahan dan terus berhenti. Jadi dia daripada awalnya 10 meter per second laju dan dia bergerak semakin perlahan. Dan kalau kamu cari gradient kat sini, gradient dia adalah negatif. Kalau negatif maksudnya acceleration is a negative. So hampir 1 jam sudah, mungkin lepas ni kamu dah kelas So jadi untuk kelas kita hari ini terlewat sikit dia ada masalah teknikal, tidak apa. Yang penting hari ini kita sudah berbincang secara ringkas berkenaan dengan introduction for chapter 2, kinematic of linear motion. Kita ada lagi I think 2 or 3 subtopic to complete pada chapter 2. That's all. Thank you. Assalamualaikum and salam sejahtera. Terima kasih.